Hi, I'm Bruce. Welcome to my Rocky Mountain lab. And today we're looking at another Keithley 179 TRMS digital multimeter. And it's a true root mean square. So you can decipher the root mean square value of a number of different waveforms. Right now we are on the DC voltage scale. We're on 200 millivolts, the lowest scale. We're putting in 100 millivolts, which is part of the performance verification right from the manual, which I can show you right here. I have the performance verification chart from the manual, and I'm going to do some readings and read off to you how we're performing. So right now, with 100 millivolts, we've got 100.000, 5 zeros essentially on the HP. We have 100.01 on the Keithley. So as long as we were within 99.93 to 100.07, we were good. And we were 100.01, which means we were 0.01 millivolts. So that's 10 microvolts off of perfect, as compared to our Hewlett-Packard. So now we go to the 2 volt range, and we want to read 1 volt on this range. So 1 volt. Hewlett-Packard's reading 1 with 5 zeros. The Keithley is reading 1.0000. Let's mark that down. Alright. We're good between 0.9925 to 1.0075, and we're dead on. Beautiful. So we'll go now to the 20 volt scale. We want 10 volts. Alright, we're reading 10 with 1, 2, 3, 4 zeros. And we are reading 10 with 3 zeros. So it's perfect. Just for your interest, if I was between 9.995 to 10.005, I would have been good. But I was right on the money. Let's go to 200 volts. Alright. And 100 volts in. We are getting 100 with 3 zeros. And on the Keithley, we're getting 100.01. If we are between 99.95 to 100.05, we were good. We're 100.01, putting us exactly 0.01 over perfect. And so we're right in the middle. Very good. Let's go to the 1000 volt range. We want to apply 1000 volts in this case, so we're going full scale. Okay, 200, 300, 400, 500, 600, 700, 800, 900, 1000. And we got 1000.00 on the Hewlett-Packard and 1000.0 on the Keithley. Perfect. So DC-wise, excellent. Let's go to the AC scales. Okay, we are in the AC mode now. AC volts, so we're in the 200 millivolt range. We're feeding our voltage in from this Fluke 5200A AC voltage source. And our Hewlett-Packard is giving us a reading of essentially 100 millivolts with 3 zeros in the decimal places. We are reading on the Keithley 100.045. 100.05. Our range of acceptability for AC, 100 millivolts range, to read 100 millivolts, we should read between 99.15 to 100.85. We read 100.05. We're right smack dab in the middle, so beautiful. Let's go to the 2 volt range. And we want to put in 1 volt. Okay. All right, we got 1 and essentially 5 zeros. And we've got 1 and 3 zeros and a 1. 1.0001. So let's 1.0001. We should be between 0.9925 and 1.0075. We are 1.0001, so we're right smack in the middle again. And very acceptable. 20 volt range. We want to go 10 volts. .0000 or 1, and we are getting 10.000 right on the nose. So that's beautiful. And for your interest, if we were between 9.935 to 10.065, we'd have been good. But we are right on the money. 200 volt range. 100 volts in. $103 zeros, and we are getting 100.08. 100.08. If we're between 99.35 to 100.65, we're good. We're 100.08. We're right smack in the middle again, doing beautiful. So, nothing to complain about there. 1000 volt range, and they'd like us to put in 1000 volts of AC, but I do not have an amplifier that would amplify my 100 volts up to 1000 to give it to me. So the highest I can do, 119.9999, so 120 volts. 120.00 volts. Okay, we are reading 119.9. So can't read the range off of this performance chart because we haven't got 1000 volts. However, in my 119.9 is flashing to 120, so it's almost it's somewhere right up near it anyway. I think I'm going to say that we are in excellent shape there. We'll move on to resistance. All right, we're set up in resistance, and we are taking our resistance from this Resistostat 2, made by General Resistance. The resistors in this box are all 0.01% accuracy, so they're highly, highly accurate. Looks like they want us to start in the 20K scale, so let's do that. 20K. And they want 19 kiloohms. We are reading 19.000, so we're right on the money. 19.000. We were good if we were between 18.99 to 19.01, but we're right on the money, so better yet. Let's go to the 200K scale. They want 190K. Alright, 190K dialed in. And we are getting a reading of 190.00 to 01, flashing up and down a little. I'm going to call it 00. It's that close. 190.00, so we're right on the money. We'd be good if we were between 189.9 to 190.1. So in the worst case, we'd be 0.01 off, not 0.1. So excellent. Let's move on to the 2000K, the 2 megohm scale. Okay. They want us to be reading 1.9 megohms. Alright, 1.9 megohms. We are getting 1900.0 kiloohms. That's 1.9 megohms, right on the money. We'd be good if we were between 1899 and 1901, but we're 19.00, so, or 1900. Beautiful. Now we go to the 20 megohm scale, and they want 19 megohms. So, well, in order to measure 19 million ohms, I'm going to have to put another resistor in series with my resistostat, because the highest I can get is 10 megohms. Well, 11 if I throw all the dials to 9. And so that's not going to get me there. So I've looked through my box of 10 megohm resistors, and I found one that is giving me a reading of about 9.99 plus, and it problem is at this range, at this high of a resistance, these resistors are very sensitive to air currents and temperature, and you'll see a lot of drifting as the air currents and temperature in the room change. If I was to just breathe on that resistor, you'd see it swing. But we are at about 9.99, which would put us at about 0.1% accuracy. So within 0.1%, I should be getting a good reading here. We'll see. Alright, so we inserted the resistor in series with the resistostat. We've got the resistostat dialed in at 9 megohms. We've got 10 megohms within 0.1% inserted in series with it, and we are settled at about 18.988. And a little bit of drift on it, but in any case, as long as we're over 18.98 and under 19.02, we're within the specs. And it appears we've got that, so we're going to move along. Okay, so those resistance measurements were all in the high ohms mode. We now go to the low ohms mode. This is a special mode that is meant to measure resistance in circuit and does not provide enough voltage to trip semiconductor devices. So you will get more accurate readings in circuit if you're going to try and do that. Of course, your circuit should not ever be powered. You read it with no power. You're trying to read a resistance only. So anyway, we're right now on the 2K scale, and we have 1.9K dialed in, and we're reading 1.9001 to 2. We'll call it a 2. And we would be good if we were between 1.8957 and 1.9043, and we had 1.9002. So we are very, very close to the middle, way in within the bounds of the accuracy of the unit. So we're good on that one. So let's go to the 20 meg or 20K. And they want us to put in 19K, so $19K. We're getting a reading right now of 19.002. And if we were between 18.957 to 19.043, we're good. We've got 19.002, again, right in the middle. Go to the 200K, and they want us to use 190K. All right. We are getting a reading of 190.09. Maybe 0.1. 190.1 is possible too. We are good if we're between 189.57 and 190.43. We got 190.09. All right, we go to the 2000K, 2 megohm range. And they want us to put in 1.9 megohms, or 1900. So 1.9 megohms. So we got 1900.0 to 2. I'll call it 0.1. We are good if we're between 1895.7 to 1904.3. We're 1900.1. So we're beautiful. So that concludes the resistance tests. I guess we should move on. Okay, well, we're on the 2 amp current scale, DC current, and we've connected up to this constant current power supply. So we're going to adjust the current as closely as we can at various steps. We're going to compare it to the current that we're receiving through this Hewlett-Packard 34401, which was recently calibrated. And right at the moment, we've got we're at 0 on the power supply, and we're reading 0.288, or if you round to the tenths of a milliamp, then it would be 0.3 milliamps, and we're getting 0.3 milliamps on this 179 Keithley. So we're going to go ahead and raise her up. Let's take her up to 50 milliamps. Well, I'm reading 49.9 on the Keithley right at the moment. I'm reading 49.7 on the HP. So we are 0.2 of a milliamp different. Let's take her up to 100. 100 right there, and we are reading 99.84, 3 or 4, so about 0.2 again of a milliamp difference at the 2 amp scale. Take her up to 500. 499.9, pretty dang close. 499.7, 2/10 of a milliamp difference again. 500 milliamps, so let's go up to an amp. Getting it to exactly an amp is going to be a frustrating challenge. I can't do it. We've got 999.6 on the Keithley. We got 999.1 on the Hewlett Packard. $999.4 on the Hewlett Packard, 1000.1 on the Keithley right now. So let's take her up to 1.5 amps. Back her off a little. $1,500.3. I'm getting 1499.5.6. 1499.6 on the Hewlett Packard. 1500.4 on the Keithley. We're rising on both just a little bit. 1499.7 on the Hewlett Packard. 1500.5. So yeah, we're approaching 1499.8, 1500.6. So that would be 0.8 difference, 0.8 milliamp difference. Yeah, 0.8 milliamp difference at 1.5. Let's take her up to 1900, and then I'm going to back off rather quickly because I don't want to blow the fuse. We're fused at 2 amps. Point 8. 1.88, 1.89, 1.9. 1.9 amps. We're reading 1.898, 1.899. 1.900.1. So we are looks like we're about 0.7. We're 1.9003, 1.889, 0.7 milliamps different at almost 2 amps, 1.9 amps. All right, I'm taking her down. And we will change our range. 200 milliamp range. So this is 1/10 or 10 times more sensitive than we were earlier. We're going to take this up to 190. Back off just a little bit. Pretty sensitive at this point. 189 190.9. Not going to be stable enough to call that. Let's raise it just a hair. .15. 190.07. We're getting 190.27, so 190.3 up on the Hewlett Packard. We're getting 190 here, so we're within 0.3 milliamps. Okay, we're going to take her down again, and we're changing the range to the 20 milliamp. And we will take ourselves up first to 10, and then we'll go to 19. 10 is a very short distance to go here. Real sensitive. Ooh. My power supply is just not going to be... You know what? We're going to change to a controlled current source that's a lot more accurate at this range. Let's do that. Okay, well, we're on the 2 amp current scale, DC current, and we've connected up to this constant current power supply. So we're going to adjust the current as closely as we can at various steps. And we're going to compare it to the current that we're receiving through this Hewlett Packard 34401, which was recently calibrated. And right at the moment, we've got we're at 0 on the power supply, and we're reading 0.288, or if you round to the tenths of a milliamp, then it would be 0.3 milliamps. And we're getting 0.3 milliamps on this 179 Keithley. So we're going to go ahead and raise her up. Let's take her up to 50 milliamps. Very gently get it up there. Well, I'm reading 49.9 on the Keithley right at the moment. I'm reading 49.7 on the HP. So we are 0.2 of a milliamp different. Let's take her up to 100. 100 right there, and we are reading 99.84, 3 or 4, so about 0.2 again of a milliamp difference at the 2 amp scale. Take her up to 500. $499.9, pretty dang close. 499.7, 0.2 of a milliamp difference again. 500 milliamps. So let's go up to an amp. Getting it to exactly an amp is going to be a frustrating challenge. I can't do it. We've got 999.6 on the Keithley. We got 999.1 on the Hewlett Packard. Again, that's 0.2 or 0.3 milliamps different, depending on when you catch it. Let's see. $999.4 on the Hewlett Packard, 1000.1 on the Keithley right now. So that would be 0.3 milliamp difference. Let's take her up to 1.5 amps. Back her off a little. $1,500.3. I'm getting 1499.5.6. 1499.6 on the Hewlett Packard. 1500.4 on the Keithley. We're rising on both just a little bit. 1499.7 on the Hewlett Packard. 1500.5. So yeah, we're approaching 1499.8, 1500.6. So that would be 0.8 difference, 0.8 milliamp difference. Yeah, 0.8 milliamp difference at 1.5. Let's take her up to 1900, and then I'm going to back off rather quickly because I don't want to blow the fuse. We're fused at 2 amps. Point 8. 1.88, 1.89, 1.9. 1.9 amps. We're reading 1.898, 1.899. 1.900.1. So we are looks like we're about 0.7. We're 1.9003, 1.889, 0.7 milliamps different at almost 2 amps, 1.9 amps. All right, I'm taking her down. And we will change our range. 200 milliamp range. So this is 1/10 or 10 times more sensitive than we were earlier. We're going to take this up to 190. Back off just a little bit. Pretty sensitive at this point. 189.9. stable enough to call that. Let's raise it just a hair. .190.15. 190.07. We're getting 190.27, so 190.3 up on the Hewlett Packard. We're getting 190 here, so we're within 0.3 milliamps. Okay, so we switched our current source to this Keithley 225. It's a digitally activated current source, good up to about 100 milliamps. Right now we're producing 10 milliamps out of it. We're getting 10.045 on the 20 milliamp scale on the Keithley, and we're getting 10.046 on the Hewlett Packard. So about 1/100th of a milliamp different between the two. Not bad. Let's take ourselves up to 19 milliamps. 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, we're getting 18.997 on the Keithley. 18.999 to 19. We'll call it 19. Well, now it's settling to 0.999, but in any case, we're about 2,000ths to 3,000ths different in milliamps. So 0.003 milliamp difference in current reading. Very minuscule. Okay, take ourselves down again. And we're going to take our range down. Okay, and right now we're going to go to the 2 milliamp range. We're going to want to input a mil. So there is a milliamp. 1 milliamp is chosen, 1.00, 1.0054, 1.0055. So basically right on the head, both meters. And let us now take ourselves up to 1.9 mils. Okay, I got 1.9013, 1.9016. So within, well, it's even gotten a little bit, we'll say within 0.3 thousandths. Yeah, so what, 300 millionths, something like that. Very, very close. Again, to within 3 decimal places, we're right on. All right, let's take ourselves down. And we're going to go to the 200 microamp scale, so I need to switch to microamps. And we've done that. Let's okay, if I go to this, we're going to be at 100 microamps here. 100.62, and we're getting 100.6 up there, so within 200ths of a microamp. So basically right on. Let's take ourselves up to 190 microamps. We have 190.27, 190.2 or 3. Actually getting more resolution out of the Keithley than I am out of the Hewlett Packard. So 0.1, less than 0.1 microamp difference. So there we are. All of the current ranges, DC current ranges, are spot on. Beautiful. Okay, well, we're into the AC current area now, and I want to try and do something to demonstrate that this thing can read AC current, at least to the accuracy that was intended. So I've read through the manual, and I see that as far as a performance verification goes, the only thing that's said is that if you pass the AC voltage verification and you pass the DC current verification, there is no need to go further with an AC current verification. So they didn't do it. That's not good enough. I wanted to be able to demonstrate that the unit is working acceptably so. It also says that the AC current is accurate to within 1%, plus or minus 1%, plus or minus 15 digits. So I went ahead and looked at each of the ranges, 200 microamp, 2 milliamp, and 20 milliamp ranges, and I saw that I had 2 decimal places in the 200 microamp range. I've got 3 decimal places in the 2 milliamp range. I'm sorry, 4 decimal places in the 2 milliamp range and 3 decimal places in the 20 milliamp range. So using the plus or minus 1%, plus or minus 15 digits, I formulated this performance verification chart for those ranges. And I figured I'd go ahead and provide a test. So what I'm doing, that AC calibrator that's up there is supposed to be able to put out up to 50 milliamps. I figure I'll go as much as 20 safely and not have to worry about it. And so what I've done is I'm feeding that into the meter. Now that's, that takes some explanation too. There is a resistance of the shunts in this meter. The shunt resistance for the 200 microamp range is 1,000 ohms. For the 2 milliamp range, I believe it's 100 ohms, and for the 20 milliamp range, it's 10 ohms. That resistance has to be taken into consideration if you're going to try and measure any resistance. I mean, what series resistor are you going to use if you already got 1,000 ohms in there, for instance? And if you go to do any measurements later on, you certainly have to keep that in mind. So knowing that I had 1,000 ohms of resistance in series with this meter at the 200 microamp range, I can go ahead and put in a 10 millivolt voltage, for instance, and over the 1,000 ohms, I can provide my 10 microamps of output. And that's what I'm doing right now. We have 10 millivolts being passed to the meter. We're connected in series. We've got AC current selected. So we're putting that 10 millivolts across the 1,000 ohms, and we are then seeing the result on the meter, and we've got 10 microamps. Now, I'm reading the voltage going across the meter here, reading that voltage on this HP, and I see that I've got 10 millivolts, 10.00, we'll call it 2 or 3, across 1,000 ohms of internal resistance, and we're getting the 10 microamps. So I can kind of have a confirmation of what's going on voltage-wise, and then checking my shunt resistance by measuring the parallel voltage. Okay, right at the moment I have 100 millivolts coming out of my AC calibrator. I'm measuring 100.036 millivolts AC on my my Hewlett-Packard, and I'm seeing that it's producing 100.045 microamps on the meter. And if I have for 100 microamps, I should be able to measure, if I see 89.85 to 110.15 microamps on the display, then I am within the performance verification range. And what I have is 100.05, which is very, very close to the dead center, so we're doing very well there. Let's try, let's do 150. Okay, we have a reading of 150 millivolts. We are getting a reading of 150.16 microamps. Let's go down to the 150. If I am reading 150 microamps, then I should be between 134.85 and 165.15 microamps on the reading of the meter to be within the performance verification. We had a reading of 150.16. Again, it's like dead center, almost perfect. 0.16 microamps off of perfect. Now let's take the last reading at 190. Here we want to read between 170.85 and 209.15. 190, dead on. 190 millivolts. And we are getting a reading of 190.2. And if we were within the range of 170.85 to 209.15, we would be accurate for the meter. We are getting a reading of 190.2, which is dead on in the middle with 0.2 microamps, so certainly we're doing well. All right, we have 100 millivolts. 100 millivolts going into the meter, and we are on the 2 milliamp range, and we got a reading of, this would be 1 milliamp we're trying to see here, and we got a reading of 0.9966. If we get a reading between 0.8985 and 1.1015, we're good. We got 0.9966. Again, right in the middle. And we are 0.34 microamps off of the reading. Off of a perfect reading. Very small error. Let us go to 1.5. Okay, 150 millivolts. And we're producing 149.64. So 100, that'd be 1.4964. If we had a reading between 1.3485 and 1.6515, we're good. We got 1.4964, again, right in the middle. We are 0.36 microamps off of perfect. Let's go to the 1.9 milliamp reading. Okay, 190 millivolts going across the shunt resistor. We've got a 1.8953 reading. 1.8953. We would be good if we read between 1.7085 and 2.0915. We're reading 1.8953 or 1.9 if you rounded that, and it's 1.9 would be perfect. We are 0.47 microamps off of perfection. Okay, let's go to the 20 milliamp range and let's reduce our voltage first. Okay. Well, what I've discovered is I'm getting more current out of this 5200A than was spec'd. So apparently I'm going to be able to do some additional readings here. We're going to read the current through both the Hewlett-Packard and the Keithley in series, and compare the readings on the Hewlett-Packard to the Keithley, or vice versa, however you want to say that. 10 milliamps on the Hewlett-Packard. We're getting 9.926 milliamps on the Keithley. .74% difference. All right, let's try 15. All right, we got 15 milliamps on the Hewlett-Packard, 14.741 on the Keithley. It's about 1.73% difference. And then finally, let's try the 19 milliamps. All right, we got 19 milliamps on the Hewlett-Packard. We got 18.733 on the Keithley. About 1.41% difference. Okay, I'm on the 200 milliamp scale, and what I'm doing here is I'm simply putting the current through both meters here. I've got it going through the Keithley and through the Hewlett-Packard. Whatever the internal resistance is in combination of the 2 meters is what's limiting my current, but I should be reading the same current on each one. And I just recently had this calibrated and it verified, so I'm going to assume that whatever I'm reading here right now in this range is good. And if I read the same on both meters, we're going to assume that they are working properly. And I'm going to produce what I can until my overload light goes on in my my calibrator. Right at the moment, we are producing 57.8 79 or 8 milliamps on the Hewlett-Packard. We got 57.8 on the Keithley, so that's good. Okay, we're on the 200 milliamp scale. I am actually outputting 191.1 milliamps. I'm getting 190.89, 190.9. So we are 0.2 milliamps different. 0.2 milliamps out of 190, and we're good. So we're reading this scale quite well as well, and I haven't tripped out. I'm amazed. Go to the 2 amp scale. I am reading 122.6 milliamps. I got 122.6 milliamps on the Keithley as well. So, Alright, this is the limit of what I can produce without going into overload. I've got 490 milliamps and I'm reading 489.8, so 0.2 milliamps different on the 2 amp scale, the 2000 milliamp scale. So we're roughly 1/4 of the way up on this scale, and we're reading within 0.2 milliamps. It's really quite accurate. So we're good. So I think I've proven that the AC current is working well. And let's close this thing up, huh?